Hi, hello dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss about determinants in matrices mathematics 1A. We are going to discuss now. Let us have a discussion. The first question here, show that determinant of 1A a square, 1B b square, 1C c square is equal to a minus b into b minus c into c minus a. So, you first consider LHS 1a square, 1b b square, 1c c square. Whenever either in row or column 3 ones are available, make any 2 ones zeros by row operations. See here, I am going to make these two terms or zeros by applying, here we are going to apply row operations. Here this is belongs to R2, this is belongs to R3. So R2 tends to R2 minus R1 and R3 value also I want to make 0. So R3 tends to R3 minus R1. So after applying this operation, so R1 we cannot disturb. So we are not disturbing that R1. 1a square as it is, you write it, dear students. After that, R2 minus R1. So 1 minus 1, 0. Next, b minus a. Next, b square minus a square. Next, R3 tends to R3 minus R1. 1 minus 1, 0. C minus a. Next, c square minus a square. After that, from second row, third row, here b minus a term is there. B square minus a square means what? B minus a into b plus a only, no? So we can write it as 1 a square 0 b minus a. B square minus a square can be written as b minus a into b plus a. Third row 0 c minus a, c minus a into c plus a. From second row b minus a I am taking common. From third row c minus a I am taking common. So taking common, b minus a and c minus a from R2 and R3 respectively. So in the determinants, whatever we are taking common, which are multiples of the determinant, so it will becomes b minus a we are taking common and c minus a also we are taking common. So the rest of the determinant will come first row as it is 1a square. In the second row 0 1 b plus a. 0 1 b plus a. In the third row 0 c minus a we have taken, no 1 c plus a. Expanding along with column 1, expand the determinant along C1, column 1, dear students. So you will get b minus a into c minus a, 1 into determinant of this only, no? So 1 into c plus a minus 1 into b plus a. So minus of b plus a, minus b minus a. So plus a minus a get cancelled. In the proof they are asking to find the result as a minus b, no? So here b minus a is there, minus take out common, a minus b, b minus c, c minus a into c minus b. Here I want to write minus b, b minus c, no minus I am taking common, minus of a minus b, c minus a, minus of b minus c. Minus into minus is plus, so a minus b, b minus c into c minus a. Hence proved. I hope you understand this, students. So slowly, step by step, you understand that. We'll move on to the next question. Yeah, the next question, dear students, very important for VSAQs. If omega is complex cube root of 1, then show that determinant of 1 omega square, omega square 1, omega square 1 omega equal to 0. So they are asking to prove this result. So consider, that means LHS, they are asking to prove the determinant equal to 0. No? So consider LHS, indirectly it is 1 omega square, omega square 1, omega square 1 omega. Here I am going to apply the row operation. On applying row operation, R1 tends to R1 plus R2 plus R3. So this is the row 1, this is row 2, this is row 3. So in place of R1 we are writing 1 plus omega square. So the first row will come 1 plus omega square. Next omega plus omega square plus 1, omega square plus 1 plus omega. So the rest of that R2 and R3 as it is, we'll write it. So omega square, and here 1 in the row 3, omega square 1 omega. We know that omega is cube roots of unity cube root of 1, then we have 1 plus omega square is equal to 0. So this is the very important root which is there in the complex number in the second year. Important result. Not only this one, omega cube is also equal to 1. So in place of 1 plus omega square, 1 plus omega square, 1 plus omega square value 0. So this determinant will comes 0, 0, 0, omega square 1, omega square 1 omega. From the properties of determinant, in any row or columns, the elements of all the elements of column or row zeros, then the determinant value goes to be 0. Since the elements of first row is 0, the determinant is equal to 0. Therefore, which is LHS, this is RHS, dear students. So hence proved. Determinant of 1 omega square, omega square 1, omega square 1 omega value is 0. Since from properties of determinants. We'll move to the next question, dear students. I hope you understand. We'll move on to the next one. The next question, dear students, conceptually good question it is. It may help in the competitive exams itself. Show that the determinant of skew symmetric matrix of order 3 is always 0. So the determinant of skew symmetric matrix of order 3 is always 0. So A is skew symmetric matrix. Let A equal to, let A be the skew symmetric matrix. Let A be the skew symmetric. What is the meaning of skew symmetric matrix? That is, A transpose is equal to minus A. So the matrix A is said to be skew symmetric matrix if the transpose of A is equal to minus A. So like this you have to consider one 3 by 3 matrix of skew symmetric. We have to assume that. Let us consider. We have to take any one of them generally. A equal to, so while writing some logic you can apply, dear students. Skew symmetric matrix, no, we need to get minus A, whose transpose. All the diagonal elements, principal diagonal elements, write zeros. So here B, here C, here A. Here is there no L shape. Here also the negatives of these values, write it. So minus B, minus C, minus A. Once if you want to check, you can check it. Just I will verify. A transpose. So transpose means the first column will become first row. So 0, B, C. Second column will become second row. Minus B, 0, A. Third column will become third row. Minus C, minus A, 0. Which is equal to minus, if you take out common from these, you will get 0, minus B, minus C, B, 0, minus A, C, A, 0. That is equal to minus A. So A transpose equal to minus A means it is skew symmetric matrix. No need to prove, just I am giving explanation for understanding purpose. So what they are asking, the determinant of skew symmetric matrix. We proved that A is skew symmetric matrix here. Now we will verify the determinant. So determinant of skew symmetric matrix, det A equal to. So how to calculate det A? Determinant of 0, minus B, minus C, B, 0, minus A, C, A, 0. Now, so 0 into anything is 0. So 0. Next plus B into 0 plus AC. Expanding minus C into AB minus 0. So 0 plus ABC minus ABC. So which is equal to ABC minus ABC 0. So when the matrix of order 3 by 3 matrix, dear students, this is, I'm sorry, before only I have to write. So the matrix A is symmetric matrix and of order 3 and whose determinant is 0, you know, this is proved. Hence proved. But one more important result also you need to learn from this example. If it is 2 by 2 skew symmetric matrix, the determinant of the delta of 2 by 2 matrix, 2 by 2 skew symmetric matrix, that also skew symmetric matrix is need not be 0. See how, sir, it will be means. I will give one example for this. Make a note, dear students. Just I will give one example. Simple example. A equal to 0, 0, minus 2, 2. So, transpose calculate. 0, 2, minus 2, 0. So minus, if you take out common, 0 minus 2, 2, 0. Absolutely it is skew symmetric. Now I am calculating determinant of A, 0 minus of minus 4 plus 4. But dear, not equal to 0 now, determinant. So the determinant of 2 by 2 skew symmetric matrix is need not be 0. This is the best example for that. But whenever the determinant of skew symmetric of order 3, here we mention that order 3 is always 0. If you come to the 2 by 2 skew symmetric matrix, the determinant is need not be 0. This is the best example. I hope you understand, dear students. If you like this video, please share to your friends and relatives. Thank you all. Jai Hind.